Hello guys and welcome back. Today we will be proceeding with our next day for the 100-day JEE Advanced question series. And guys, I am really sorry because my videos are a bit late, because I hope you had seen I had two flights in a single day and the second one was delayed. So I didn't have any network connection, or like I was not in a situation to record. So I couldn't make the video. That's why this is coming a bit late, but don't worry. From now on, things will be really punctual. Okay. So guys, today's question is actually taken from, once again, Maths Explorers. And this question is, I like this question very much, so I thought I should pick this up. So guys, if you want, you can try this question out yourself once. Like, very much on little bit of calculus is there, but mostly this is on properties of conics. So really good question to actually test what you have studied. Okay. So you can try it out. You can pause the video. I will wait for a few seconds and then start off with the solving. Okay guys, I guess now it's time for us to solve this. So before starting off, let's give a short reading. So we have to consider the ellipse x squared by 6 plus y squared by 3 equal to 1. We have to let E1 denote the locus of the points of intersection of a pair of perpendicular tangents to E. Okay, and now this statement that I read right now, the statement from let E1 to perpendicular tangents to E, the second line here, this is actually something they are telling you something. Okay, and if you have not read your theory properly, then you will maybe not be able to do this at this point. So basically I will write that first. Our ellipse E is given as your x square by 6 plus y square by 3 is equal to 1. Okay. And now if you see, E1 denotes the locus of the points of intersection of pair of perpendicular tangents to E. So we know that from our theory, we know that the locus of the points of intersection of a pair of perpendicular tangents to any ellipse, it is the director circle of that ellipse. Okay, so basically E1 is the director circle for the ellipse E. That's what they have tried to say. Okay, so guys, I guess you know the equation for the director circle, which is x square plus y square is equal to here a square plus b square. So E1 will be x squared plus y squared is equal to 6 plus 3, 9. Okay, this thing is your E1. Okay, now after this, a vertical line is passing through the point PH comma 0 and it intersects E and E1 at Q and R respectively. Okay, respectively in the first quadrant. So Q is for E and I guess your R is for E1. Now let the tangent T to the ellipse at point Q intersect the positive x-axis at the point S. So S will be something like something comma 0. Okay. So we have to find out which of the following statements is or are true. So in these, I guess the area of triangle PQS maximum and minimum values, the maximum area of triangle PRS and angle OQS, whether it is constant or not. Roughly this is the question. Okay. So guys, I am changing the page now and I will solve this. Okay, so first thing is, because P is given to be h comma 0, so let's do one thing. P is your h comma 0. Okay, so guys, what I am doing is, because Q is also lying on E, and if you look at our question once, it is said that a vertical line through P is actually intersecting this ellipse at Q. Okay, which means that h is actually constant, so we can solve. If we give h square by 6 and let this be say yq square by 3 equal to 1. So from here guys, if you solve this, then you will actually get your yq to be equal to, I guess, root under 6 minus h squared by 2. Okay, yeah, it is root under 6 minus h square by 2. So this is your yq, that means your q point, it comes out to be h comma root under of 6 minus h squared by 2. Okay, this is your q point. And after this guys, I guess we can go on to the others. So for the other points, actually R is intersection with E1, I'm sorry, R is intersection with E1, which is the director circle. So in the same way, if we again put P on the director circle, that means h square, and let's treat this as yr square is equal to 9. So from here actually your yr, it comes out to be root under 9 minus h square. Okay, so if this is root 9 minus h square, I guess your r will come out to be h comma root under 9 minus h squared. Okay, so guys, we have got q, r and p was given, and now to find out s. S was, I guess, point of intersection with tangent, and that tangent was actually coming from your point q. Okay, so guys, if we write down our ellipse once, which is x square by 6 plus y square by 3 is equal to 1, then the tangent to this ellipse will be xq by 6 plus yq by 3 is equal to 1. Okay, so if we put the values, I guess this thing will come out to be hx by 6 plus of, and let's keep it as yq for the time being, we will put it at the last because it is a big value, is equal to 1. Okay, so if we evaluate this, like, see, it is lying on the x-axis, this was said. Okay, so basically this term will actually go to 0. That means from here you will get your xs as 6 by h. Okay, this was actually the equation of the tangent at q, and from here you get xs as 6 by h. So basically if you see, your s point has now come out to be 6 by h comma 0. Okay, so guys, I guess we have all the points ready now. So now we can move on to calculating the area of the triangles. I guess there were two triangles given. Okay, so let's evaluate that. Okay, so guys, I have written down our 4 points of reference in this question just for looking. So first thing is we have to find out triangle PQS area. Okay, so for that actually I am calculating PS, the length of PS. So length of PS actually comes out to be, I guess, root under of, this is, okay, we don't need a root under. PS is like both are on x-axis, right? So h minus, I guess, okay, wait, h comma 0 and 6 by h comma 0. So I guess it will be 6 by h minus h. So this comes out to be 6 minus h squared by h. This is your value of PS. Okay. So now after this, if we look on to finding out the triangle PQS area. So area of your triangle PQS, if we want to write the expression for this, it will be simply half base into height. So, okay, and if I want to somehow plot triangle PQS in a coordinate axis, I will try to do that. Let's draw it roughly. Okay, so let's say P is somewhere here, PH comma 0, and Q will be, obviously it's a vertical line, so Q maybe will be somewhere here. Q is your h comma root under 6 minus h squared by 2. Okay, and going to r, if we actually compare root 6 minus h square by 2 and root 9 minus h square, okay, let's take a arbitrary value. Let's say we take 1, so this is your root 5 by 2, and if we take 1 here, this is 2 root 2. Okay, so root 2.5 and 2 root 2 is 2 into 1.14. So if we compare the values, I guess the comparison will give us this thing. Okay, 2 root 2 will be greater. So if your like 2 root 2 came out of root 9 minus h square, so I guess r will be somewhere here. And like it's pretty obvious because your director circle, like, see, this somewhere here you will have your ellipse and director circle will be something like this, right? So very natural. And if we talk about our s was 6 by h comma 0. So if we see 6 by h is greater than this, so maybe 6 by h will be somewhere here. So roughly your triangle plotting will be easier now. So if we plot our triangles, let's use a different color for this. Maybe I can use red. Okay, this is red or magenta, I don't know. I guess pink. Okay, PQS. So PQS will be this triangle. I guess it's a right angle triangle. And your another triangle that was given, it was PRS. So PRS will be this triangle. Okay, really cool diagram. So I guess both are actually right angled. So not a difficulty, we can directly use half base into height. So if we use half base into height to calculate for triangle PQS, it will be half into PS distance, which is 6 minus h squared by h. And I guess this thing will be y of q, like this part. Okay. So I guess if we go on to calculate this is coming, okay, let me write 6 minus h square by 2h, and root under of this will be 6 minus h square by 2. So area of your triangle PQS, this thing is coming out to be 6 minus h squared whole power 3 by 2 by 4h. Okay. Okay, wait, not 4h, 2 root 2. It's 2 root 2 h. Yeah. Like this is your value of triangle PQS area. Okay. Job is not still done. We have to do a lot of calculation still, manipulation like maximum, minimum value. But before that, let's find out triangle PRS also. Okay. Okay. So very simply, triangle PRS, area of triangle PRS. This will be equal to half into base, which is 6 okay, not base actually, height, 6 minus h square by h into yr. Okay. Okay, wait, this was the base, I'm sorry, this was the PS distance, and this thing will be your height. So if we add, like, multiply this, I guess this will come out to be 6 minus h square by 2h, and this thing was root 9 minus h square. So this thing is your area of triangle PRS. Okay, I will box this. This is your area of triangle PRS. Okay, so now let's go on into the calculation part, like a lot of minimum, maximum and stuff was asked. So guys, first thing is, let's deal with your area of triangle PQS. Okay. Okay, and wait a minute, I will just check. Okay, so one very positive thing is that in all our options, we have to evaluate everything in the interval 1 to 2. So we have to find out minimum area and maximum area of triangle PQS, maximum area of triangle PRS, and angle OQS, whether it is constant or not. Okay, so guys, let's do one thing, like let's find out the extremum values. I guess that will be okay. We will get the maximum and minimum value there. Okay, so let's do that. Okay, and guys, just a thing, like I don't know whether there is sound coming in the background or not. I am at the moment recording from an airport lounge. Okay, so if you get any background sound, just ignore that, because my mic was not working a few days ago, so I am now doing on a headphone mic, which I guess might catch some sound. I don't think there will be any sound, but still, if you get any sound of some plane flying or something, then just ignore that. Okay, I don't think there will be sound here. Anyways, so guys, area of triangle PQS in the interval 1 to 2, we have to check on the extrema. Okay, so first thing is our area of triangle PQS. Okay, let's bring in the expression once. Area of triangle PQS was this thing, 6 minus h square whole power 3 by 2. So for the time being, to make the, because we have to differentiate, right? So to make things simpler, let's take a function u of h as equal to 6 minus h squared. Okay, so if we now try to find like write area of, okay, I am writing area of triangle PQS like this. Okay, APQS. So this thing will actually come out to be u power 3 by 2 by 2 root 2 h. So now if we differentiate DAPQS DH, or rather we can call this as A dash PQS, this thing will come out to be, I guess, if we evaluate. Okay, I have this thing ready with me, so I am writing directly the result. Okay, just do that calculation part, like I'm writing everything, just the calculation I will jump one step. So this will come out to be 1 by 2 root 2 outside, 3 by 2 root u, and here you will have u dash, or rather du by dh, into 1 by h, minus of u powered 3 by 2, and this thing will come out to be 1 by h square. Okay, and because actually 1 by h is differentiated as minus 1 by h square, so this plus which was supposed to be present here, it became minus. Okay, so guys, 1 by 2 root 2 this is, and if we evaluate this, I guess, okay, wait, I'm directly writing the result out. Okay, this is minus root u, and inside this will actually come out to be 3 plus of your u by h square. Like, I have not jumped a lot of steps, little bit of manipulation you have to do. So guys, if we now put our u, I guess this will come out to be minus of root 6 minus h squared whole divided by 2 root 2, and this thing is actually coming out to be, I guess, 2h square plus 6. Like, okay, it's correct, 2h square plus 6 by h square. So it's the final value of this will come out to be minus of 2h square plus 6. If you want, you can take 2 common out from here also, but I'm not doing that right now. Root 6 minus h square whole divided by your 2 root 2h square. Okay. Now guys, one thing, like, we have found out a dash pqs, right? So little bit of analysis now. This particular part is always positive. Root, so always positive. Again a square, so always positive. But very bad thing, there is a minus before. So if there is a minus before, that means your a dash pqs, because everything else is positive, no chances of becoming negative. A dash pqs as a function of h, this thing will be less than 0 for h belonging to closed 1 to 2. Okay, so we have found out the nature, and let's do one thing, like, now put the values at the extrema. So at h equals to say 1, because it's our lower extrema. So h equals to 1, at h equals to 1, a pqs of 1. Like, I am denoting it as a pqs as a function of h. So a pqs as 1. This will come out to be equal to, I guess, 6 minus 1 power 3 by 2 whole divided by your 2 root 2. Okay. So this thing comes out to be 5 root 5 by 2 root 2. So guys, now if we go on to calculating your this thing at h equals to 2, this will come out to be a pqs at 2, and you can understand it's a decreasing function, right? Because the first derivative is less than 0, so it's a decreasing function. So if this is a decreasing function, obviously the value will be less than this. So this will come out to be 6 minus of 4 power 3 by 2 whole divided by your 2 root 2 times 2. So this thing will come out to be 2 root 2 by 4 root 2, which is equal to half. So guys, actually we have got two options, the verdict for two options here. First verdict is minimum value of area of PQS in the interval. We are talking about in the interval 1 to 2, where h belongs to, sorry, this is closed, 1 to 2. In this particular interval, minimum value is half, not 1 by root 2. Okay, so option A automatically becomes wrong. And maximum value of area of triangle PQS is equal to 5 root 5 by 2 root 2, which is correct because it was given in option number B. So B is one correct option. Okay. Okay. So guys, after this, I guess the job for triangle PQS is done. So now let's move on to our triangle PRS. And in a very same way, APRS as a function of h, I am writing it like that. And this thing was given to be equal to 6 minus h square by 2h multiplied by root 9 minus h square. Okay. Okay. So guys, like, at this position, you can go for directly putting this, but still I have found out it will be a lot of calculation. Okay, like, see, if you don't want to find out the first derivative for this area of triangle PRS, there will be absolutely no harm. you can go for directly substituting h equals to 1 and 2. But still I am finding it out so that you have an idea. So DAPRS DH, which is your A dash PRS as a function of h. Okay, this will be a little long, so I am not going into the calculation much. This took me, I guess, 3 to 4 lines approx, like little bit of calculation. Okay, I am directly writing out the result, don't worry. If you want, you can calculate. This will come out to be 2h power 4 minus of 9h squared minus 54, and this thing is whole divided by 2h squared root under 9 minus h squared. Okay, so guys, one thing that this particular part in the denominator, this thing is greater than 0. Okay, you can see. So like everything depends on the sign of this thing. So let's do one thing now, like take this particular thing to be a function capital Q of h, which is equal to 2h power 4 minus 9h squared minus 54. So if we take this as a capital Q of h, then capital Q of h at h equals to 1, if we find this out, this will come out to be 2 minus 9 minus 54. So I guess this is coming out to be minus 61, which is less than 0. And now if we go on to the next value, which is Q of h at h equals to 2, this is coming out to be 2 power 5 minus 9 into 2 square minus 54. Okay, so guys, if we evaluate this particular thing, like wait, I will try to evaluate. 2 4s are 16, 5s are 32 minus 9 4s are 36 minus 54. Okay, minus 4 minus 54, so this is coming out to be minus 58. Okay, so both are less than 0, first thing. And like in between this interval, because the extrema values, both of them are negative, so very like obviously I guess all the values in between will be also negative, which means A dash PRS as a function of h, this thing is less than 0 for h belongs to closed 1 to 2. Okay, so guys, I guess this thing will also be a decreasing function. So if we calculate APRS now at 1, putting h equals to 1, like here's our expression, I guess this thing will come out to be 6 minus 1 by 2 root 9 minus 1. So I guess this is coming out to be 5 root 2. And APRS at h equals to 2, this thing will come out to be 6 minus 2 to the 4 2 by 2 to the 4 and root 9 minus 2 to the 4 5. So root 5 by 2. Okay, this thing is coming out to be root 5 by 2. So in our option number C, they had asked us what is the value of the maximum area for triangle PRS, and it was given to be 5 root 2. So basically option C becomes correct. Okay, and this thing will be the, like this is the maximum value and this thing is the minimum value, but minimum was not asked. Still we have found it. Okay, okay, so guys, this is the 3 options, and now option number D is a bit interesting. In option number D, they have asked us whether angle OQS, this particular angle, will remain constant or not. Okay, so for that I am actually returning to the diagram we had drawn a while before. Okay, so guys, this is the origin, this is the point Q. So if we join this point, then actually if you see, I guess I will try to highlight this with the blue color. This blue colored triangle is our triangle OQS, and this angle here is your angle OQS. Let's take it to be theta. Okay, so guys, they have asked us whether angle OQS, or like it's given that angle OQS is constant, but we have to see what is the validity of this statement. Okay, so guys, I guess the best thing for determining in this situation the angle will be using vectors. Okay, we will use vectors, like best thing to do rather than using trigonometry and anything else and complicating the situation. So let's do one thing. Let's find out QO vector. Okay, so O was the origin. So QO vector, I guess it will come out to be minus H, comma, minus YQ. Minus H, comma, minus YQ. So this thing will come out to be minus H, and Y of Q was root 9 minus H square. So minus root 9 minus H square. Okay, this is your, okay, wait, I actually wrote this for R. Your YQ was 6 minus H square by 2. Okay, this is your QO vector. And similarly, in a way, if we find out your QS vector, this thing will come out to be 6 minus H square by H, comma, minus YQ. So 6 minus H square by H, comma, minus root 6 minus H square by 2. Okay. So guys, if we find out QO dot QS now, I hope you can understand where we are trying to head, because we are finding the dot product. So if we find out QO dot QS, okay, so let's see what this is coming to. Okay, so I calculated this and this is coming out to be H square minus 6 by 2. Okay, the value of the dot product. Okay, so guys, now we have to, like, I hope you can understand where we are heading to, right? We are trying to find out cosine theta from the dot product formula. So we have to also find out your mod QO. So if we find out mod QO square, this will come out to be H square plus 6 minus H square by 2. So this is coming out to be H square plus 6 by 2. So your mod QO vector is equal to root under of H square plus 6 by 2. Next thing, if we find out your mod QS vector square, this thing will come out to be equal to 6 minus H square. This is 6. This is whole divided by H whole square. And same thing again, this will be plus of YQ square. Okay. So YQ square is 6 minus H square by 2. Okay, so guys, if we manipulate this particular thing, this is coming out to be, I will write here, 6 minus H square. Like, you can take a square common if you want also, maybe it will make it easier. 6 minus H square into 12 minus H square whole divided by 2 times H square. So actually mod QS, this thing will be root under of this. Okay, so guys, we have everything in place to find out cosine theta. So cosine theta, the angle in between the vectors QO and QS, this will come out to be the dot product H square minus 6 by 2, and this is whole divided by your value of the moduli. So root H square plus 6 by 2, and once again this thing will be under root of 6 minus H squared, 12 minus H squared whole divided by 2H squared. Okay. So guys, if we manipulate this a little bit, very easy manipulation actually it will be. This will come out to be a minus here. H root under of your 6 minus H square minus of H root under 6 minus H square, and this thing will be whole divided by root under H square plus 6 and multiplied by 12 minus H square. Okay. Yeah. And I hope you can understand where this minus came from, because I flipped this. Okay. To do cancel 1 6 minus H square. So guys, this is our final cosine theta product, like cosine theta value. So theta will be cosine inverse of this. So let's find out the cosine theta values at 1 and 2. If they come out to be same, very good. If they don't, then it's not constant, right? So for h equals to 1, let's take this to be, say, cosine theta of 1. This will come out to be minus of root 6 minus 1 is 5, and this is root 1 plus 6, 7 into 11. So this thing is coming out to be minus of root 5 by 77. And in the second place, on h equals to 2 cosine theta 2, this thing is coming out to be your minus of, okay, theta 2 is h equals to 2, so 2 times of root 6 minus 4 is root 2, whole divided by 2 to the 4, 10, and this will come out to be 2 to the 4, 8. So I guess a little bit of cancellation here and there. This is coming out to be 2 root 2. So okay, 2 root 2 is getting cancelled. So this is minus 1 by root 10. Okay. So in our option number, last option D, it was written that the value of theta, the angle OQS, it is constant for all values in closed 1 to 2. So if that was the case, then theta 1 should be equal to theta 2, or rather cosine theta 1 should be equal to cosine theta 2, but this thing is not true, which means option D becomes wrong. Values are not constant. Okay. So guys, the question is finally done. Our correct answers for this particular question will be B and C. Okay. So guys, I guess you had a good time with this question, because like this was I will not say very lengthy, like pretty balanced. Okay, this can easily come in your JEE Advanced, literal perfect JEE Advanced level question. Okay, and good use of properties, good use of vectors, also good use of your conics, director circle. Like director circle came even this year in JEE Advanced. Okay, so if you still don't know what is a director circle, and you maybe saw it for the first time in my video, or maybe you saw it in my video and then it plugged into your mind that okay, yes, there is something present like this, then it's a like a really warning sign, red mark. Please open your books right now, notes right now, and revise whatever in conics you have. Okay, because see, theory without conics is like solving sums without knowing maths. I'm telling you. Okay, if you don't know theory in the exam hall, it's all wasted. And if you know the theory, then like a question, it's like a free lease. Okay, because generally if the question this year, generally the questions which came on properties of conics, they were not really hard based on properties, but if you know the properties, then you can easily calculate. Okay, so guys, I guess this will be the end for today's video. I hope you liked this video. If you like my content, do like, share and subscribe. Any doubts, always do come in the comment section. And one more thing guys, if you want me to bring more originals, do drop something in the comments. Okay, so that's it for today guys. Thanks for watching.